Hi, Owls. This is Mrs. Myers. Last week, you took a practice ACT, and this week, we're going to go over the top 4 most missed questions on the science section. These were the top 4 most missed questions, 26, 27, 32, and 33. You'll notice they were towards the end of the science section, so probably you were getting tired, right? You'd already taken 3 other tests beforehand. And it looks like the answers for these were about what you would have gotten if you just picked a letter. So that's just a good strategy reminder. If you are running out of time on the science ACT or any ACT passage, at the end, just pick a letter of the day. Say it's C, pick C for every single one, and you'll still get about what this was. However, I do want to note before we get into this, the Olathe West ACT science scores were actually very good. We had the highest science score of any of the Olathe high schools. So good job, guys, on ACT science. Okay, let's get into these. Here's question 26. The question is in the orange box, and then the information from the passage you need is to the right. Let's read question 26. At 1 atmosphere of pressure, the melting point of ammonia is NH3, you don't have to know that, is 77 degrees Celsius. So if it's above 77, it's melted, it's liquid. If it's below negative 77, it is solid. And the boiling point is negative 33 degrees Celsius. So if it's above negative 33, it boils and becomes gas. If it's below negative 33, it's still liquid. So it's a liquid somewhere between negative 77 and negative 33. Based on this information and the description of the apparatus, and apparatus just means like the tools that you're using for your experiment, when the ammonia exited the condenser, was it more likely a solid or a liquid? So we need to figure out what temperature it was to figure out if it's a solid or a liquid. Okay, I'm going to look over at my diagram of the apparatus. That just means the diagram of the tools they used. I don't see anything about temperature in the picture, so now I'm going to read underneath. I don't have time to read every single word, so I'm just going to be looking for the word condenser, which is the key word that they told us in the question. So number 1, I don't see anything about condenser. Number 2, nothing about condenser. Number 3, I see it was a negative 50 degrees Celsius condenser. Okay, if it's negative 50, that's between negative 77 and negative 33. So that tells me it had melted, but it had not boiled yet. So it was a liquid. So it can't be F, that says solid, not G, that says solid. It's either H or J, it's a liquid. Okay, H says because the temperature was higher than the melting point and the boiling point. That's not correct. J says because it was between. Negative 50 is between negative 77 and negative 33. So our answer for 26 is J. All right, let's look at our next most missed question, number 27. Consider the trial in experiment 2 that produced 550 kilograms of ammonia. Okay, so I know I'm looking at experiment 2. So I found the section that said experiment 2 because they tell us here experiment 2. And I'm looking for 550 kilograms of ammonia. Okay, if I look at my axes, I see amount of ammonia here. I find 550, it's around here. And usually on the test, I will draw a line along that so I know which section I'm looking at. That means I must be looking at this trial here because that is the only one that had 550 kilograms of ammonia made. So I'm looking at this dot, okay? Let's see what the rest of the question asks. Based on figure 1, okay, so something in figure 1 is going to be important later. I'll circle figure 1. The number of cycles needed to complete the reaction in this trial was most likely what? So our answer will be somewhere here on this y-axis, number of cycles, okay? How do I connect these two graphs? These are always tough on the science section. They give you something on one graph and you have to connect it to a different graph. I try to find what do the graphs have in common, okay? So here I can see we've got temperature on the y-axis, or on the x-axis, sorry. And I see temperatures in my key here, okay? So let's look back here. I know I'm at these 550 kilograms, which tells me the only trial that's important is this one, the white circle, which tells me we're at 300 degrees Celsius. Okay, 300 degrees Celsius. Is there anything about 300 Celsius on the other graph? Yes, there is. Here we've got temperature, 300 Celsius here. Okay, so my answer for number of cycles will be somewhere one of these 4 dots. Okay, I'm not sure which of these 4 dots it is. It doesn't tell me if I'm working with any of these catalysts. So I need to go back to the first graph to figure out which catalyst it is. Okay, there's nothing about catalyst WXYZ in this picture, so I'm going to have to look in the text. When I look in the text, I see this graph is about catalyst Z. Okay, now go back to your second graph. Catalyst Z is the star. Okay, so the star's value for number of cycles, it looks like it's less than 5. So my answer here for A, less than 5. Okay, so you can see why this one was a highly missed question. You had to go back and forth between 2 graphs. You had to find a little detail in a paragraph. It was putting a lot of different pieces of information together. Do I have any idea what this is actually talking about with pressure and ammonia and catalysts? No, but I can match all of these different words and figure out where all of my data points line up. Okay, let's do our next most missed one. 32. Suppose for 2 sound waves, a 150 hertz wave and a 1100 hertz wave are simultaneously emitted from a speaker into air at 20 degrees Celsius. I'm going to highlight that, might be important later, and 45% humidity. Okay, based on figure 2. Okay, that's why I pulled up figure 2 here. We know it must be important. As the waves travel away from the speaker, the intensity level of which wave will be more likely to decrease at the greater rate due to attenuation. Okay, so they're basically trying to figure out which one will have the greatest amount of attenuation. Okay, I don't know what attenuation means. I'm not a physics teacher. I will look in this paragraph and I see that attenuation is abbreviated by this alpha. Okay, so they're basically asking which one of these, the 150 hertz or the 1100 hertz, will have a bigger alpha A. Okay, all right, and they told me to use figure 2 to figure it out. If I look over at figure 2, I can see for alpha A, the solid line 1000 is the highest, and then the dashed line, and then the solid dot line. Okay, so it looks like when the hertz is biggest, the alpha is biggest. Okay, so if I'm comparing back to my question, 150 and 1100, this number of hertz is biggest, so that one will probably have the biggest alpha. Okay, so I know it's not F because that says 150. I know it's not G because that says 150. It's either H because that says the 1100 or J 1100. Let's see which one's correct. H says because the alpha is less for that one. That's not right because I saw when I had a bigger number, my alpha was more. And this one says because the alpha is greater for that. That is correct. So 32 should be dry. Okay, sorry about my dogs. All right, last one. 33. The graph below shows for sound waves of 3 different frequencies how alpha varies with relative humidity in the air at a particular temperature. Okay, so they don't tell us the temperature. They just tell us here are the different alphas for different sound waves at different humidities. Make sure you're always looking at the axes, the labels, right, on graphs. All right, based on figure 1, so I pulled up figure 1 here. Figure 1, the particular air temperature is most likely which is the following. So they're just asking, okay, we give you this graph, what temperature was the graph made at? Okay, so one of my answers is going to be found on this x-axis. I'm basically trying to match this data to the x-axis. Okay, let's see, and they tell us figure 1 is at 10% humidity. So if I focus on 10% here, relative humidity, 10%. This data here, these 3 data points, 1, 2, 3, what temperature do they line up with? Okay, let's look at the first data point, the 1000 hertz. It is 12, 13, 14, about 14 for alpha. Okay, so 1000 hertz, about 14 for alpha. Is it 14 at A, negative 20? Nope, that's too low. Is it 14 at B, 0? That looks like 14, that matches. Okay, is it 14 anywhere else? It could be at 20 or it could be a 60, but that's not an answer choice. Okay, so that tells me it's either 0 or 20. So it's either B or C. If I was running out of time, I could just pick one out of a 50-50 shot. Okay, let's look at our next wave. We've got our 50 hertz. That value for alpha is 8, 9, about 9. Okay, let's look at 0 is the 500. Sorry, I said 50, should be 500. 0, it's about 9. 20, it's about 4. So that tells me that 0 is the correct temperature. Okay, so the answer for 33 should be B. All right, those were tough. It makes sense that we missed those. They were tough. You had to put a lot of things together. Usually the common thread, which science ACT questions that kids miss a lot, is you're putting two different graphs together. So you have to really pay attention to labels and kind of match all of the different terms to find the best answer. All right, thanks for watching. Hope you have a great week.